Okay, let's give you guys some practice now. So come up with the parametric equations to describe this particle moving from here to here within 13 seconds. Okay, so let me illustrate it. So the particle starts at 2,3, 13 seconds later it terminates at 7,7. Okay, so come up with the parametric equations. So press pause and have a go. Okay, so to do this, notice that it's moving 5 across and then 4 up. It's moving 5 across and 4 up. So the technique is to concentrate on making the particle moving from the origin 5 across and then 4 up. So it would be right here. So it's moving from the origin to here. Well, concentrate on making the particle moving from the origin to here, and then later on we can add 2. We can translate it. Add 2 in the x direction, and then add 3, and then that will then give us the path of our particle. But for the time being, concentrate on making the line from the origin to here. So if I were to give you this, let's say x equals t, y equals t squared. You see, this thing here is really easy to draw because t coincides with x. So when given this, let's say when t equals 1, 1 squared would be 1, which would be somewhere here. When t equals 2, 2 squared would be 4. When t equals 3, t squared would be 9. The point here is that when x matches up with t, then it becomes really easy to draw these parametric equations because it's simply in this form here. So when t matches up with x, it becomes really easy to sketch. So if you want to come up with the parametric equations for this line, make x to be t. So set x to be t, and then you want the line to climb with a gradient of 4/5 t. So this here will describe the line from the origin to here. But then we need to translate it. Hang on. We need to bear with me. We need to translate it. 2 across and 3 up. So now we need to translate it 2 across, so that would be +2, and then move it 3 up, so +3 in the y direction. So these would be your parametric equations to describe the particle, to describe this line here. But now we need to incorporate time. So to incorporate time, when you want it so that when t equals 0, the particle starts here. 13 seconds later, you want it to terminate right here at 7/7. So to incorporate time, we need to think slightly differently. So you start here, 5 across, 4 up. Hang on. So imagine from here to here is 1 second. So just imagine for the time being. So it's 5 across and 4 up. The trick to incorporate time would be for us to cut this up into 13 equal pieces. So imagine there are 13 equal pieces, 13 seconds. And then in the y direction, cut up into 13 equal pieces. And then what that means is 1 increment of time, you would have moved 1 across and 1 up. So that would take you to here. Another increment of time would be you moving 1 segment across and then 1 segment up. And then another increment of time would be you moving across another segment and then up another segment. So that would take you to here. So the point here is that you've got 13 equal segments in the diagonal direction. So now 1 second, 3, 4, 5, and so on. 13 seconds it will take you to here. So what you do is you get your t cut up into 13 equal pieces. So you get your t cut up into 13 equal pieces, but then you want it to move across by 5. So put a 5 here. You want to move it across up by 4. So this here would also describe the line in this direction. But now we need to translate it. We need to move it 2 across and then 3 up. Okay, so we need to we need to move it across 2, and then we need to plus 3. So your final parametric equations will be given by these. Hang on, let me type this up. 5t over 13 plus 2, and then 4t over 13 plus 3. So by the time it gets to 13 seconds, it will terminate right here. So get yourself a graph plotter and actually try it for yourself. By the time, if you get a graph plotter and change this to A, add a slider A here, and then set A from 0 to 13, and then later you can slide A back and forth. So by the time it gets to 13, it will terminate right here. When it starts, it will. Well, let me illustrate it. So hang on. So your final equations will be given by this. Hang on, 5t over 13, and then plus 2, and then you've got 4t over 13 plus 3. So let me illustrate it with a graph plotter. So hang on. So if you punch in these equations, so look at this. You punch in your equations and then add A as a slider, so you can slide A back and forth. So when time equals 0, you can see it starts at 2, 3, and when A gets to 13, it will terminate dead on 7, 7. So if you get it your graph plotter and plot these things in and then slide A back and forth, you can see it for yourself. Okay.